Right, so these are the objectives today. We're going to learn the things that we didn't do already. We didn't do this thing called difference of squares. Boom. Boom. This is not part of this chapter. It's next chapter. It's in the SOL bullet. And then we got to do this one too. But the first thing we're going to do is we did these already, right? We did the simple quadratic trinomial. We did the greatest common factor. But we got to do these three. And it's this one I call not simple, which is probably the hardest thing that we do. And it comes up often, all right? It just comes up in every chapter. There's something that's got to be factored, and you got to do this. And we don't do a good job remembering how to do it because there's a lot of steps to it, a lot of steps. This is the same slide was up last class. Right, so by not simple, we mean, remember, this is the standard form of a quadratic expression, ax squared plus bx plus c. No parentheses, highest degree term on the left. The a, b, and c are real numbers of some kind. The a does not equal 1. That's wrong. Oh yeah, the a does not equal 1, because if it did, we would call that our simple quadratic. So this is an example of what we mean by a not simple quadratic trinomial. Right? Whenever you see that there's a number in front of the x squared, you got to say, okay, I can't do that by that simple one-step process. Think of two numbers, and it's just that simple. What does the EG stand for again? When I write this EG, just says for example, right? This is an example of a not simple because of the A is 2. There are a lot of times you can avoid having to do this factoring. I mean, we don't learn factoring just for the sake of factoring. We learn it because it's the way you solve equations. And I'll tell you, when I was a kid, when I was your age, and we learned this stuff, if you couldn't do the simple quadratic factoring that we already did, then use quadratic formula. You just use quadratic formula. It always works. It's given to you. Just use it, And you probably be more successful with that than having to follow these 6 steps. But we teach it for sure. So these are the steps for factoring something. The first step is you can't just, because of the 2 that's here, you have to multiply the a times the c, right? In this case, that's 2 times negative 3 equals negative 6, right? Now, we need to find the factors of negative 6 that add up to negative 5, right? That's the first step. Find the factors of AC, meaning the first number times the last number, that add up to the middle number. Again, so we would have to say, well, let's see, it's negative 6. That means one's positive, one's negative. Because they add up to a negative, the bigger one is the negative. So let's see, 6 only has like 2 choices, right? It's 1 times 6 or 2 times 3. And if the bigger one is negative, those are your options. Which one of those add up to negative 5? Right? These are the 2 that add up. So that's the first step. You got to find the numbers that add up to the middle. The factors of AC that add up to B. Okay, now second step. Split the middle term, right? The middle term is negative 5x, right? If we said that negative 5 equals 1 plus negative 6, then let's write it like that. Let's write 2x squared. I'm going to write it in this order. Minus 6x plus 1x minus 3. Right, so I've just taken the middle term and I've split it up into two terms. Because isn't that the same thing? Negative 6x plus x is negative 5x, so I didn't change the value of anything here. Okay. The next step, right? I'm going to do something here. Edit, copy, edit, paste. Okay. The next step says group the first two terms and the last two terms. Okay. So put in parentheses 2x squared minus 6x. Okay. Now this plus, which is in between the second and the third term, that goes in between the parentheses, right? That is an addition, right? We're not multiplying these parentheses, not yet. Okay. And then I've got the x minus 3. See how that works? Group the first two, group the last two. That's this step. Okay, now factor, greatest common factor factoring, each set of parentheses. Like what's the greatest common factor between 2x squared and 6x? 2x, right? There's a 2 in common, and there's at least one x in both terms. So take a 2x in front. What's left inside the parentheses? If I factor out, if I divide 2x squared by 2x, there's still one x that's in there, right? I divide 6x by 2x, minus 3, right? Don't forget the minus. And the last set of parentheses, there is no factoring to do. So just write down x minus 3. Okay, now notice that at that step, what's inside parentheses is the same. Right? The x minus 3 is what's in parentheses, and it always will be with this method. If it's not, then you did something wrong. Right? They got to have the same x minus 3 right here. Okay, now, I know this is maybe a step that we might never fully understand exactly what's going on, but it's kind of mechanical too, in terms of, you know, what I'm really doing here is now I've got two terms. Right? Terms are separated by pluses and minuses for subtraction. So this is a term, and this is a term, right? Separated by that plus. But what's the common factor in these terms? No, x minus 3. Remember, factors are things that are multiplying. This x minus 3 is multiplying times x times 2. So, and that's in common between this term and this term, right? So I can factor it out. Greatest common factor factoring would say, take out the x minus 3 from both terms, and then what would be left from this term if I took away the x minus 3? 2x, right? And what's left from this term if I factored out x minus 3? 1, right? Remember we said last time, you want to, if it looks like you're factoring out the whole term, there's really a 1 left behind. I mean, think of it. If I divide x minus 3 by x minus 3, that's 1. So you need to have the 1 in there. Okay, so that is the final product right there. That is the factoring of that expression. And again, you could confirm that by doing a FOIL, right? 2x times x is 2x squared. 2x times negative 3 is minus 6x. X times 1 is plus x. 1 times negative 3 is minus 3. Combine like terms, 2x squared minus 5x minus 3, which is same thing, same thing. Right? We're good? Jaden, are you? Okay. Now, let me go back. This is the same problem, but, you know, I wrote when I picked out the 1 and the negative 6, you know, notice how I wrote them with the negative 6x plus x. I kind of reversed the order. And I want to show you what happens, because this is going to happen. About half of the time you're going to run into this situation. Let's say that I wrote it like this: plus x minus 6x. If I just switch the order of the two terms. Okay. When I get to the next step where I group the first two and the last two, watch what happens, right? Here's 2x squared plus x. And now it's not a plus in between parentheses, it's a minus. It's a subtraction, right? And when I take the minus in front of parentheses, it means in this next term, it's 6x plus 3. Because the minus times the plus gives you the minus. Right? If you didn't change the sign of that, then you would have just changed the value of the expression. And that always happens when you've got a minus in between the parentheses. That's why when I've got one factor which is plus and one which is minus, I always try to write the negative one first so that I don't have that situation. So you could choose that. The only time you can't is when both are negative. Then you're going to have to deal with it. But all the rest of the time, you can kind of manage your way around it. Now see what happens. Factor this set of parentheses. The greatest common factor is between 2x squared and x. So just an x, which leaves us with 2x plus 1, right? What's in common between 6x and 3? There's a 3, so you take out the 3. That's 2x plus 1. And again, now in parentheses, I've got the same thing, 2x plus 1. So I factor that out. And what's left, right? From this term, x. From this term, minus 3. Which is the same thing that we got when we did it the other way. It just, we had these reversed. But again, by commutative property, it doesn't matter. And I'll just say that, let's see, 2x squared minus 5x minus 3. There are times, right, that if you really had to factor these things, they don't give us so many examples of this, they don't look for like terribly big numbers or complicated numbers or things like that. You might, if you looked at that right there, have said, well, look, if I'm gonna factor that, then I know that in the parentheses, definitely the first, it has to be like 2x times x. There's no other options here to get the positive 2x squared. We always start with a positive. So that we know that that's a 2x and that's an x. And there's only two factors of 3, right? It could be plus, could be minus, but you can sometimes just guess and check your way around this, right? You could say, well, what if I make it minus 1 plus 3? Okay, just try it. Well, definitely I know I've got the first term right and the last term right. I just have to check the middle terms. If I did that, I would have 2x times 3 is 6x minus x, that's positive 5x. Okay, that's wrong. So let me change that to a plus and that to a minus, and if I checked it, it would work. Okay, that's right. So you might be able to guess and check your way through a lot of these problems, because you do see a lot of times that the numbers they use really don't have that many factors. There's just not that many possibilities anyways. Okay. Good. Okay, let's do another one. So again, when you look at that first number, you see the 4. You say, okay, well, unless 4 is a factor of every term, so it means you could take it out, then you're going to have to factor it, right? You're going to have to go through this process. And so first step is 4 times 3 is 12. Can you think of factors of 12 that add up to negative 7? What are going to have to be the signs of those numbers? Well, if they multiply to give you a positive, they're either both positive or both negative, right? Since they add to give you a negative, they're both negative. Okay. Now think of the factors of 12. 1 times 12, 2 times 6, 3 times 4. Do any of them add up to 7? 3 times 4, right? So we're going to go negative 3, negative 4. So 4x squared minus 3x minus 4x plus 3. Okay, once you've got your numbers, you split up the middle term. Then what do I do? You group them, right? What I said grouping, whatever, parentheses, group the first two, group the last two. So when I'll do this, 4x squared minus 3x minus, and now what goes in the second set of parentheses? Since this is a minus in between the parentheses, 4x minus 3, that flips. Because again, I'm not trying to change the value of anything here. When I introduce these parentheses, that minus in front is going to change the sign of what's inside. So this minus times minus makes plus. So that's the right adjustment to make. Okay, next step would be factor each set of parentheses. What's the greatest common factor of 4x squared and 3x? There's just one x in there, right? 4x minus 3 minus 4x minus 3. So again, what's in the parentheses, same thing, right? So on the last line, you're definitely going to have 4x minus 3. And what goes in the other set of parentheses? X. Coming from here is x. Coming from here is minus 1. You know, what if you put the parentheses there and you didn't change the sign, and then you got here and they weren't the same? Yeah, but you'd be pretty sure that was the right one. So just change that. You know, if you got that one wrong, and then that one is probably the one that's right. Just change it to be like that, because you probably did everything else right about it. So that is the factoring. Now, I'm going to show you one thing. Take, for example, the one we did, I think it was the first one we did in the homework last night, right? X squared plus 3x plus 2, right? Now, when we factored that, we just said, what are the two numbers whose product is 2 and the sum is 3, and you said 1 and 2, right? And it was a one-step process. You were done, okay? The book last year actually taught you to do that problem like this problem, okay? And a lot of students did. Only at the very end, they said, oh, by the way, since A is 1, you don't need to do all that. But still, a lot of kids choose to use this method when actually they got something they can do in one step. I mean, they do it like this. They go, 1 times 2 is 2. Find the factors of 2 that add up to 3, okay? And they correctly pick the numbers 1 and 2. And they come in and go x squared plus x plus 2x plus 2. And then they group the first two, x squared plus x plus 2x plus 2. And then they factor each set of parentheses, x times x plus 1 plus 2 times x plus 1. And then they factor out the x plus 1. They get x plus 2 times x plus 1. You know, but the thing is, they knew that at the very first step. There's no reason to do all this. And so many times, after having correctly picked the right numbers there, they don't make it through the process correctly. So don't find yourself in that habit. If maybe somewhere along the way somebody taught you to do that. That's why we use this A equals 1 as its own case. It's a one-step thing, very hard to get wrong. I mean, if you got the numbers, you're done. Done. You don't want to go through all of that and then risk not doing every step correctly and getting a wrong answer. Okay. So try to do that one for yourself. Did you find the two numbers? You did? Okay, now when you take out the x, then there's no x there. It's just 2x plus 3. And what's the greatest common factor between 4x and 6? Right. I know Sam got it. No? Sean got it, right? No. Let's see this here. They broke that up right? 2x squared. Factor 2x. X plus 2. Where's your 3? You factored a 3 out of that. 3x plus 6. That's why you got the x plus 2, right? Should there be a 3 right there? Jose, what you got? 2 times 6 is 12. Multiply the first number times the last number, 12. Find the factors of 12 that add up to 7. Hello, Chris. Did you do it? You got that right. Got that right. Got that right. Okay. You're going to take out 2x from both of those, right? There's an x in common too, so you do that. And this one you had to factor out 3. Okay. 2 times 6 is 12. What are the factors of 12 that add up to 7? 4 and 3. Okay, so split up the middle term. 2x squared plus 4x plus 3x plus 6. What's that? It doesn't matter. You flip the order, it'll still come the same. Okay, group the first two terms. Group the last two terms. Right? Factor each set of parentheses. What's the greatest common factor for this first set? 2x, right? And what's left? X plus 2. Right? What's the greatest common factor between 3x and 6? Plus 3. And since x plus 2 is in common to both of those, I can factor it. And what's left is, in this term, 2x, and in this term, plus 3. Right. When you've got a plus in the middle, right? In the middle right there, sometimes I just group them on the same line. Right? I just, like right there, just put the parentheses, because it doesn't change anything if you do. There's no reason to write it again. It's just when you got the minus there, you got to be a little extra careful. If you put it on the same line, then you need to erase that and change the sign. So that's probably the hardest factoring that we do. Okay? And that's, this is all downhill from here. Right? Now we just have to look at the two special patterns. How would I factor that one? Does anybody recognize what you could do to simplify that? Yeah, everything's divisible by 2, right? So if you looked at it and you said to yourself, that's got a 2 there, that's that not simple thing. I got to go through the 6 steps, right? That means I got to go 2 times negative 44, negative 88, find the factors of negative 88 that add up to negative 18. You're like, oh my gosh, the numbers are too big. I'm not going to be able to do this. But when you notice that each one is divisible by 2, then factor out the 2, right? The greatest common factor, x squared minus 9x minus 22. The Okay, now what's in the parentheses, right, is a simple quadratic. Can you think of factors of negative 22 that add up to negative 9? I mean, what are the factors of 22? I mean, it's either 1 times 22 or it's 2 times 11. One of them's got to be negative. The bigger one's negative. So which one of those adds up? The 2 and negative 11. So this is x plus 2, x minus 11. Right? So it was a two-step process. Instead of a six-step process, it was a two-step process. So don't think every problem you get, just because it's got an a does not equal 1, that it's necessarily the sixth step. See whether you could simplify it by factoring it out. You might be able to. We're good? Okay, I think that's, okay. Now, before we do the next kind of factoring, I just want to show you what happens. I mean, this in itself is an exercise that, you know, we usually get wrong, not just in this class, but every class I've ever been in. I've read books about this. How is it that you do x plus 3 squared? Got it. What do you think you would do to perform this operation? Okay, here's what you don't do, right? You don't take that 2 and just move it in on the x and move it in on the 3. Okay, remember, what does it mean to say you're going to square something? You're going to multiply it times itself, right? So what is being multiplied by itself? X plus 3. So this is actually x plus 3 times x plus 3. And that is a FOIL. You have to multiply that, right? You can't just do x squared plus 3 squared, right? And so this is x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. Right? So if you would have just done the x squared plus 3 squared, you would have been missing the middle term. And it would have been wrong. Okay, how about this x minus 4 parentheses squared? What's that? Okay. When something like this, right, this is a quadratic trinomial, right? But if we factored it, right, you would say, what two numbers? The product is 9 and the sum is 6, and you would say 3 and 3, and you would get to this, x plus 3 squared. That's why this trinomial right here is called a perfect square trinomial. And that becomes its own method of factoring, right? We have a way to factor perfect square trinomials. Right? Now let's look at the x minus 4 squared. Again, not x squared minus 16, right? It is x minus 4 times x minus 4, which is x squared minus 8x plus 16. Right? 2x plus 5 squared. 2x plus 5 times 2x plus 5, which equals, right, it'll be 4x squared plus 2x times 5 is 10x. And then you're going to get another 2x times 5. It'll be another 10x. And then you're going to get the 5 times the 5, which is 25. So notice what we've got here, right? You've got the first term, 2x squared. That's that. You've got the last term, which is 5 squared. That's that. And then you've got 2 times 10x plus 10x the inner product, right? What do you get when you multiply 2x times 5? You get 10x. So the middle term, when you do a perfect square trinomial, is always 2 times the first times the second, right? It always works that way. 4x squared plus 20x plus 25. Now, if you were presented with this as a factoring problem, you'd probably look at it and go, let's see, 4, it's going to be that not simple quadratic kind of thing, 6 steps to do. 4 does not divide evenly into, it does not divide into any of those, all of them. It divides into that, but it doesn't divide into that. So you'd feel like you're stuck. But if you recognize, 4x squared, 4 is a perfect square, right? That's 2 squared. And 25, 5 is a perfect square. That's just 5. By any chance, is the middle term 2 times 2 times 5, which would be 20? Yes, it is. If you recognize the pattern, then you just go right to that and you don't do the 6 steps. You could just, this is a perfect square trinomial. So you're looking for that pattern. The first term looks like a perfect square. The last term looks like a perfect square. And the middle term is exactly 2 times whatever was being squared here and whatever was being squared here. Right, that's the pattern. So look at this one right here. Again, now this is another reason, I don't know whether anybody took a multiplication table. I put them over there by the calculator so that you could, right? But at the bottom of the sheet, I've put the perfect squares because it comes up all the time. And if you don't know these well, then it might help to have this a reference right there. So do we recognize 9 as a perfect square and 49 as a perfect square? Right? What number squared is 9? 3, right? So this is actually, this first term I could write like 3x squared in parentheses. And what about the last term, 49? 7 squared. So now, I still don't know whether this is a perfect square trinomial. It will be a perfect square trinomial if the middle term just happens to be 2 times 3 times 7x. So 2 times 3 would be 6. 6 times 7 is 42. That's it. Right? The middle term is 2 times 3x times 7. Right? All that together is the 42x. So I would know right away this thing equals 3x plus 7 squared. You know, if I don't recognize that pattern, again, I might just say, well, then I guess I got to do that, 6-step process. What's 9 times 49? 360, 396? No, 341. What are the factors of 341 that add up to 42? I mean, none of us want to do that, right? If you could just recognize the pattern. I mean, we know what it's going to be. It'll be 21 and 21. Okay, so let's try another one. I think I got another one. Okay, do we recognize the first number as a perfect square? Is the first number a perfect square? It's 5 squared, right? So that's 5x squared. Okay, how about the last number? We've already dealt with that, right? That's 7 squared. Okay. So what is, what's the check I need to do now? What is 2 times 5 times 7? 2 times 5 times 7. 2 times 5 is 10. 10 times 7 is 70. Okay, it's it. So we can factor this like 5x. And because the middle term is negative, it'll be 5x minus 7. Right? If it was a positive, that would have been a positive. What 2? No, the 2 is because, remember, when you multiply, if I did a 5x minus 7 squared, right? That would be 5x minus 7 times 5x minus 7, right? And the 5x times 5x is this. The 7 times 7 is that. And the middle term is 5x times negative 7 once, and then 5x times negative 7 again, twice. That's where the 2 comes from. The middle term is always made up of 2 times the multiplying of that times that times that. It's just part of, that becomes part of the formula. Okay, let's see. So try to do that one the same way. If you recognize the first number as a perfect square, Jose, head up. I mean, you could almost by inspection, you know, if you're good with your perfect squares, you could probably say right now, what is it? I think Sam should have it by now. You should have it by now. You're a quick thinker. Deshaun's got it. You got it? What you got? Correct. And you could almost just see it, right? I mean, who else has got it, do you think? Cody? Correct. He's got it. But there's not a lot of work to do. If you recognize the first number is a perfect square and the last number is a perfect square, so that's good. So the only check you do is, what is 2 times 2 times 3? 12. So that means this is 2x minus 3 squared. Did you get it? Jaden, you get it? Yep. Yep. Janine? And remember, write it like 2x minus 3. Oh, you did. Let's see. Okay. Almost right. Okay, the only thing is, since the middle number is negative, then it's 2x minus 3. Okay. I mean, there's, I would say more than half are getting this. Again, so the first number is 2 squared, right? So you would say this is like 2x in parentheses squared. This one is 3 squared. And so the only check is 2 times 2 times 3, 12? It is, right? That means that your factoring is 2x, and you just have to decide, is it plus or minus? Is it plus or minus? Because that's minus, it's minus. Done. Right? That's perfect square trinomials factoring, which is it's not a terribly common one, but it's part of the SOLs, and you know, you'll see it a little bit. The next one is like really common, really, really, really common. It's the last thing. We're almost done. Right, that's called difference of squares. Right, and difference of squares means the difference, meaning the subtraction of things that are squared. So the general formula is a squared minus b squared, right? The a is squared, the b is squared, and there's a subtraction in between. That's the difference of squares. So again, in order to use the difference of squares, you've got to recognize you've got a perfect square in front of you. You know, if you don't see it for what it is, then you won't think the right method to solve it. That's why you need to know your perfect squares. And if you don't, oh, you know what? I said I was going to make copies of this, and I didn't. Copy multiplication tables. I mean, here's the pattern, right? This formula depends on the fact that you've got two things that are being squared. When clearly the x is being squared. The 4 does not show that it's being squared, but it happens to be a perfect square, right? What number is squared is 4? 2, right? So if you write it like this, right, which would be x squared minus 2 squared, right? Now it's exactly in the pattern of difference of squares. So the way you factor it is, right, a squared minus b squared is a plus b times a minus b. Okay, well, in our problem, what is it that represents the a? A is x, and what is it that represents the b? The 2, not the minus, right? The minus is part of the formula. So in place of the a, put an x. In place of the b, put a 2. Right. How about the next one? What number squared equals 36? 6. So, I mean, you don't have to write this middle step if you see it already, but if I write it like x squared minus 6 squared, now it fits the pattern exactly. So how would I factor that? How does that factor? X plus 6, x minus 6. It's that simple. What if I said x squared minus 100? What number squared equals 10? Or equals 100? I just said it, 10. Okay, so how does it factor? X squared minus 100. X plus 10 times x minus 10. How about x squared minus 1? What number squared equals 1? 1. So how does it factor? X plus 1, x minus 1. Okay. When we get to later on, we're doing, what the chapter on rational functions, rational expressions, and all that. There's a lot of embedded factoring in there, right? And a lot of it is this difference of square stuff. And I guarantee when they put it in there, in their mind, they're thinking, let's just put an easy factoring thing in there. We're not trying to make this something about factoring. We would just like to use something kind of easy. So they use a lot of difference of squares and greatest common factor because they think that those are the easiest. Unfortunately, we struggle with them sometimes. And we don't factor them very well. But this is a pattern that I think you could recognize. Yeah. That's it. That's it. I mean, later on when we learn to solve equations by factoring, we won't be quite done yet. Okay, what about this one? It's 2x and a 5, right? This is 2x in parentheses squared minus 5 squared. Okay, so how does that factor? 2x minus 5, 2x plus 5. So it doesn't matter the order, right? I'll write it this way. 2x minus 5, 2x plus 5. And remember, you could FOIL that, right? If I FOILed it, notice what happens if I FOIL this one here, right? The x times x is x squared. The x times negative 2 is negative 2x. The x times positive 2 is positive 2x. And the 2 times negative 2 is minus 4. So the middle terms cancel, and they always will, right? So cancel. That's why all that's left is the x squared minus 4. Boom. Right, if you FOILed this, you would get 2x times 2x is 4x squared. You would get 5 times negative 5 times 5 is negative 25. And then you would have 2x times positive 5 and 2x times negative 5. Cancel. No middle terms. So, could you factor that? Do you know what number squared is? No, that's number 121. I mean, you know how to take a square root in your calculator, don't you? So you could always just check it that way. If you don't know what number squared equals 121, put it in the calculator. Did everybody get that number? Ellie? What number squared is 121? What's that? 12? Nope. It's 11. Minus 11 squared, okay? So how does that factor? X minus 11, x plus 11. Piece of cake, right? What's that? Okay. Okay, let's see. I don't remember what I got after this. Try that one. Okay, and all you got to think of is what number squared equals 81. I'm just going to go right to the factors. What are the factors? 9x plus 1, 9x minus 1. Okay, we're good. Bree, you good? And the only thing I'd point out is something like this, right? If you have to factor something like this, right, you look right away, it's a difference, and there's an x squared, but neither 2 or 18 are perfect squares, right? So what kind of factoring do you need to do first? Yeah, greatest common factor. There's a common factor of 2, right? So most of the more difficult problems, you end up having to do a greatest common factor factoring first, and then what's left inside might be able to factor at one more step. Like after I take out the 2, okay, now that's a difference of squares. 2 times x plus 3 times x minus 3. Good to go. Okay. Sam, good? Okay. So that was the 2 days of factoring. And like I said, this one part here, sum and difference of cubes we get to in the next chapter, but everything else is pretty much done. And the homework, you know, I just trying to pick problems a little bit from that not simple quadratic, a little bit from the perfect square trinomial, a little bit from the difference of squares. And because I'm kind of picky, I'm not trying to like overcomplicate. There are some even numbers in there because I just felt like you'd have more success with them, right? It's not just plain old odd numbers, whatever you get.